Good morning, everybody. Welcome back to lecture number 16. Today, remember, we have our quiz on Thursday. The quiz, you need to memorize the circuit. Okay? You need to memorize the exact model. And the circuit number 2 and circuit number 3. You need to memorize the equations of V primary over V secondary over A. You need to memorize the KVL equations. You need to understand how to derive them. You cannot memorize them. You need to understand them. Okay? You cannot memorize the KVL equation. Here, EP equal IS. These things you have to derive them yourself. Okay? Otherwise, you'll memorize it. Okay? So you know what to memorize, you know what to not memorize, or you are not allowed to memorize it. Let me put it that way. Because you'll be required to show the steps in the VIP example. So note takers, you guys don't take notes here. Who's taking notes? Right? No, you don't take notes. Who's taking notes here? Or in the video, in the YouTube? So you use NT notes? You don't have to. I would rather you watch the lecture and take notes when you watch YouTube. When you watch YouTube, take notes, okay? Those who did not attend today, I'm going to give information that is not recorded, that is useful for the test. So that's the price they're going to pay. Even though I take YouTube videos, you still have to come to class. Because if you don't show up to class, I cannot deliver the best lecture I can. So remember circuit 1? This is the original circuit. Was this referred to primary or referred to secondary?
To primary.
Referred to primary. Why? Because I see RS prime, XS prime, VS prime. What did I tell you about this circuit? We have to do 2 KVL and 1 KCL. KVL 1, KCL, KVL 2. Circuit 2, they said, oh no, we don't want to do it that way. Let's move the parallel element here so that we do 1 KVL and 1 KCL. Students who get stuck in the exam, their only solution to survive is to use this circuit where you take away the parallel element. How many equations do they need to do? Just 1 KVL across this loop. That is why, Ya Umar, I'm telling you, do not memorize the equations. Because you have, depending on which circuit you use, you have to derive the equations. However, you may memorize, for example, the model itself. And I told you how to memorize it. There's 2 ways to memorize it. Either by thinking about the losses. Okay, I know this is parallel, this is series. Or you just memorize it by practice. Or it might be provided in the problem statement itself. It might be provided, okay? In the problem, in the example itself. One more thing is, remember these 2 circuits? Which circuit? Is it circuit 1 or circuit 2 or circuit 3?
2.
No, that's circuit 1 because the parallel element in halfway. There is elements before, there is elements after. What is the difference between the 2? This one is we refer the secondary to primary. The circuit number 2, we refer the primary component, including the parallel, to the secondary side. That's why you see here, for example, VP prime, IP prime, RP prime, JXP prime, RC prime, JXM prime. Or you see it divided by A squared, or multiplied by or divide by A or multiply by A. So yes,
So it's more work. Why would someone like do that?
because you are an engineer, when you are required to do accurate modeling, you have to do the more work.
Isn't the same? The second one isn't the same.
No, circuit 1 has two versions. Refer to every circuit has two mirrors. Either you refer everything to primary or you refer everything to secondary. That's why there is more work.
يعني في أسئلة تعتمد إنه أسوي.
Yes. Now today we will solve example referring to secondary. But I love circuit 1 because circuit 1 is the one that they use for the software. In real life, when you go and work for any company, when you do simulation, you are not allowed to simulate circuit 2 or circuit 3. Use circuit 1 for simulation. That's why we want to use it. It's not more work, it's just one equation more.
Right.
Okay? So last time, I showed you how to do this example, and we solved it. You agree with me? I'm not going to solve it again. Watch YouTube. We have the solution on YouTube. I didn't put it on the slides. Okay? Remember, we have rated, we have operating values. Today we will talk about voltage regulation. What is voltage regulation بالعربي?
نظم
تنظيم الفولتج.
تنظيم الفولتج. تنظيم الجهد. What does it mean? Remember the refrigerator example? Can I connect my refrigerator to 260 volts? What is the rated voltage of your refrigerator? When you open your refrigerator, look at it from the back. What does the sticker say? 220. Can I operate it at 260?
No, because there's
No. Can I operate it at 180? RMS?
yes.
No. It's 220. You missed 40 volts. Why you missed 40 volts? You have to run it at 220 or 210 or 230. That is the range. And they usually write it like that. They usually tell you 220 to 240. It means if you operate at 260, bad. If you operate at 200, bad. Why they write a range in your devices? For the voltage regulation. So we need to regulate the voltage at the transformer secondary side to match الثلاجة. So loads connected to secondary are designed to operate at a constant voltage. So who's more important? Secondary voltage to be maintained fixed or the primary voltage?
Second.
The secondary. Because the primary voltage, it is the job of Saudi Electricity Company to control it.
Yes.
Maybe they increase it, maybe they decrease it. And we saw in the previous example, what was VP? 478 to serve a load of 220 after reflection 440. When the current is drawn through a transformer, the load terminal voltages changes. In order to compensate for this problem, we need to increase the primary voltage to maintain a secondary voltage. Why? Because every time I have a different current, I have a different voltage drop across these circuits. So if the current is high, I have a higher voltage drop here, and I have a higher voltage drop here. Then I need to have a higher voltage here to maintain a constant voltage here. So a large voltage change is not desirable for the loads, and more light bulbs, for example, when we connect them to the transformer, they start to fade down because you have to increase the input voltage of your transformer. But in reality, the voltage is 220. That is why, do you remember my transformer? What was the apparent power? 5,000. So you are allowed to connect 5,000 over maybe 70 watt bulbs. 5,000 over 70, max. If you increase, your voltage regulation doesn't work, and sometimes the transformer itself would trip to protect the transformer and protect the load and protect the source. So the voltage regulation is measured where? At the low side. Now, think with me. If I connect a load of 220 volts, maybe I supply at the primary maybe 460. What is the voltage at full load? 220 in the load side. Why? Because I cannot have a refrigerator anything more or less. Let's say I remove the refrigerator. Would the primary voltage appear on the secondary? Yes, the 440 would propagate and it would be maybe 260 or 250. So voltage at no load is higher than voltage at full load divided by voltage full load. In other words, do I want to have my voltage regulation big or small? Smaller is better. Because smaller, it means even if I remove the load, there is no deviation in the load voltage. Let me tell you the example one more time. I have a transformer, 440. A equal 2. So what will appear here? 220. Let's say I connect the ladder. Now the current is high, this becomes what? 460. So voltage regulation is what? Voltage at no load. Remove the ladder. The utility has to maintain 460 no matter what. The utility cannot have 440. 460. Connect the ladder.
440.
Something like that. It may not be clear, but we'll solve an example. It's not 440 when you connect the ladder, it is the voltage that appears here after the reflection. It is actually this voltage after the reflection. Completely practical. This is not accurate. We need the exact numbers, but this is just an estimate. Why voltage at no load is higher? Because Saudi Electricity Company fixed the voltage at this transformer at 460. They know that this customer connects to 20 volts. Okay, let's just give him 460 and whatever he deals with, let him deal with it, okay? Because if I provide this customer 440, he will not get 220 because there will be voltage drop. So me as Saudi Electricity Company, I need to keep it at 460. That is why I say it's measured at the load, and it's V no load minus V full load over V full load. Efficiency. Do we want to operate at high efficiency or low efficiency? Very high efficiency. We need to do it. So, but transformers are static devices. They do not move. Because they do not move, they don't have friction. They don't have windage. They don't have any other rotating losses. So we are lucky that transformers generally have high efficiency up to 99%. So if I see a transformer with less than 90% efficiency, I should not use it because I have no excuse in transformers not to have such high efficiency. Look at this circuit, for example. What is this circuit? Circuit 1 or circuit 2 or circuit 3? No, circuit 2. Parallel هنا اليسار. Is it referred to primary or referred to secondary?
Primary.
Referred to primary. How do I know that? V is prime, I is prime. So all the equations in this slide has to refer to primary voltage quantities. Efficiency is output power over input power, but input power is actually losses. What type of losses do I have? Copper and core on the R. We do not consider flux linkage or magnetization losses in the efficiency because we care about the real power. Customers pay for what? Real power. They don't get charged for the magnetization current of the Saudi electricity transformer nearby. They do not get charged for the flux leakage power, reactive power that is lost. They just get charged about the copper losses will AD with hysteresis. Three things. What is the copper losses? In this circuit, it is IS prime square times R equivalent, referred to the primary. What is the iron losses? VP square over core losses, RC. If I use circuit 1, use EP, don't use VP. Get it?
If I use
Circuit 1, you use the voltage here, which we call it EP. We did not call it VP. What is the output power? It is Vs prime times Is prime times cosine theta. Why? Because I'm referring the load now to the primary side. It's a single phase, there is no three. So the real power output is that. So if I combine these equations, I can have another general form that looks like that. But is this referred to secondary or referred to primary?
secondary.
Referred to secondary. So I can use it. I can have efficiency equations referred to primary. I can have efficiency equations referred to secondary. How did I know that this efficiency equation referred to secondary? Because there is no primes here on the S. Okay?
في سؤال دكتور.
Yes.
في الباور في الايرون هو حط لك ار او وش صار ليش هذه؟ في الباور حقت الايرون فوق في السلايد اللي فوق على طول
Yes.
حط فوق
This slide or previous slide?
البريفيوس سلايد
Okay.
الباور حقت الايرون قسم على ار او
It's not RO, it should be RC. There's no RO here. And this one, I guess, is equivalent to P. And everything else is right. Fix it. YouTube. So you can use 1 minus losses over input power. If you use this, you can use the circuit. Remember, if I have a transformer of efficiency 80%, is it good or bad?
بعد
Bad. 90, barely good. 95, good. 99, perfect. Get it? So you need to have a sense of what is good, what is bad. If I have voltage regulation of big number, good or bad?
بعد
Bad. Bad, we talk about maybe 8% is bad, 2% is good. Voltage regulation.
يذكرون الافشنسي في المواصفات؟
Yes. This efficiency example, does it use the circuit reflected tool primary or the secondary? Secondary. Why? Because I don't have Vs prime. So you can use this equation directly. Again, is it useful to memorize the efficiency equation? No, because I don't know which circuit I'm going to have. Maybe I'm going to have circuit 3. Maybe I'm going to have circuit 1. Maybe I'm going to have circuit 2. So this one is for circuit 2, referred to secondary. This one is Vp square over A over R. You can call this just C. Okay. Again, the purpose I'm showing you 3 different slides is do not memorize. You can do it referred to primary. You can do it referred to secondary. Referred to secondary. Is it clear? Let's do an example, number 4. What is this example? 100 volts KVA A. Is this rated for transformer or rated for the load or rated for transmission line? What is this?
Transformer.
Rated for the transformer because it connects it to the distribution transformer. Is it single phase or three phase?
Single.
Single phase. Why? Because for transformers, unless I tell you it's a three-phase transformer, it is usually a single-phase transformer. Big transformers are three-phase. Distribution transformers are single-phase. Some you might do distribution transformer three-phase. Again, you see everything in the field. What is this information? 8,000 to 277. Step up or step down?
Down.
Step down. Is it? What do I benefit from this? What quantity? A. So what is my A? Calculators. Calculators. Please, if you don't want to use calculator, there is no point. You can watch the YouTube. Okay?
28.9.
Where is your calculator? Where is your calculator? Why did you not bring the calculator? You're in the quiz, you're not allowed to use iPad calculator. Why you practice on something that you're not going to use? iPad would calculate it faster than this calculator. Where is your calculator? Where is your calculator? And there is no point of staying. So if you want to leave, you can. Where is your calculator? Where is your calculator? Where is your calculator? Good. So we only have two people who didn't have calculators. So now you're missing. So my advice is join your colleague and help him. So choose a colleague and he allows you that. How about you? You already have my calculator. So what is A?
28.9.
I want high efficient calculations. Please, we don't want to waste the class time. Because in the exam, I'm going to squeeze you in time. That's my game. That's the only thing I can do in 360. Squeeze you in time. How can I know the A plus engineer from the C plus engineer?
كلنا إن شاء الله يخلص.
No, possible. I never allowed. Half of you will get A's, half of you will get anything else. That's the best case scenario. Anyway, you're competing against each other. Just kidding. Remember, do your best, focus on yourself, okay? You're not competing against each other. Point what?
9.
Now, find, okay, are these quantities referred to primary or secondary or
No, it's not.
refer to nothing? Because these are the primary with the primary side. These ones are for the secondary side.
دكتور ال 100 كيلو فولت امبير هذه الباور.
This is the apparent power, not power. You have to use the right terminology. It's the apparent power. It's not the power. When we say power on a skit, we mean P, real power.
Wow.
It's the apparent power. It's not only apparent power, it's the rated apparent power of a single phase transformer. That's the right terminology. Okay? That's the right way of saying things. Find the equivalent circuit referred to the low voltage side. So remember, I'm memorizing it. Resistor, and I have the parallel, and I have resistor, parallel. Am I referring it to the low side? إيش معنى low side?
برايمري.
I'm referring to
برايمري.
wrong.
حسب السبب.
Secondary wrong. The right answer is this. حسن. So So the question says at the low voltage side. I don't know what is the low voltage. Is it the primary or the secondary? So go back to that. So which happens to be the low side?
Secondary.
Secondary, 270. So I refer it to where?
Secondary.
So now he's asking you, what is the voltage here? VP or VP prime? What is the current here? IP prime here. RP prime here. JXP prime here. RC prime. Remember, the parallel component belongs to primary. Here. Here. RS, no prime. Here. What is the current? IS, no prime. What is the voltage? BS, no prime. Get it? Step number one, or not step number one. I need to calculate this, that. So what is RP prime? Give me numbers. Divide by a square, yalla. Divide 5 over a square.
6 milli
6 milliohm. What is XP prime? 7.2 milliohm. What is RC prime? 60 ohm. What is XM prime? 12 ohm. Get it? You need to practice on the slides and homework and some of the book problems and the old exams if we cover them. If we cover them. Some of the old exams we did not cover them. For example, auto transformers we are not going to cover them in the problem. Some of the old exams have them. We are making 360 more useful, more practical. Do I need to go and write them on my circuit? Waste of time. Let's continue.
So, the VP prime.
Let me check the camera. Okay, be careful. Right around 30 minutes, it might turn off. What is your question, Mahal?
VP prime, nice.
You are right. I made a mistake. I need to have a VP prime. So we finished this circuit, and we have the calculations. Here he didn't have VP prime. He decided to have it VP over A. That is okay. It's up to him. I don't care. Problem B. Assume that this transformer is supplying rated load. Key word. Whenever I see the word rated, I should panic. I should panic. Seriously. Because rated has lots of information baked in. داخلها. What does rated load mean? ايش معنى rated? Easy way to remember. By design. Rated يعني by design. فلما أقول لك rated load, you can replace rated, call it by design load. By design transformer. So rated load at 277, does it match a transformer output voltage? Yes. At 0.85 power factor lagging, what is the transformer's input voltage? What is the VR? Silly joke that I make. If you ask anyone on the street what is VR, they will tell you what? Virtual reality. Our engineers, we don't believe in virtual reality. We believe in voltage regulation. Okay? Please. If I ask you in the exam, what is VR stands for? Don't want to see you. When I work for a company, I don't want to name it, but probably you will figure it out. They used to have virtual simulation team. So they hire people from graphic design, maybe industrial design, maybe some of those majors that are simulation based. And they will ask them to visualize transformers, visualize transmission lines, because engineers, we are not good at graphic design, we are bad. So when you all have a startup, let me guess who's gonna have a startup. I don't know. Moroha. Moroha, when he opens his startup, you should have some budget for graphic design, okay? You need to hire people to do the transformer simulation for you. Don't ask the engineers to go and draw it for you, okay? That's just one practical aspect. I told you I'm gonna make a phone call because I have something has to do with work. Now, Assalamu alaikum. Done or not yet? Okay. You're at 4-1. Okay, building 4, خلاص? Okay. Text me when you reach when you submit the reading. Thank you. Sorry. So it has to do with work. Now, what will happen is, in the previous problem, what did we use for the load? What power we used? He already told you the power was consuming 20 kilowatt. Now he didn't tell me. So what is the power that the load consumes? The rated apparent power of the transformer. Get it? That is why I need to panic whenever I read the word rated, because it has lots of information inside it. It means the load that is connected, it is by design of whatever the transformer is providing. So, to get the current, IS, is IS prime or not a prime?
Not a problem.
Not a prime. I connect now to the circuit that is referred to the secondary. Should I use this equation P over V power factor? No, I don't have it. So what should I use? S over V. Single phase or three phase? Raspberry, single phase or three phase?
Single.
Single phase. So what is my S? 200 or 100?
100.
100.
100.
kVA divided by 277 volts. So what is the magnitude of my current? 361 amp. To get the angle, we are professionals. What is theta? Plus cosine inverse of 0.85. What is this number?
That's 1.78.
31 point.
78.
Not only that, what is theta I? What is my reference, theta B? The 277 angle 0 at the load side. 0. What is theta I?
13.
Minus 31.6 degrees, or 0.7. So what is IS? No, no prime. What is IS? 361 angle minus 31.78 amps. Get it? Continue. Now, I need to do my first KVL. I have this, I have that, I have this, I have this, I need to find E. What is E here? Is it EP or ES? Think. Think.
EP prime.
EP prime. Or I can say ES.
Okay.
When you reflect E prime, it is ES.
Okay.
So let's use ES. It is more friendly. You can use EP prime. That's the same quantity. It's very similar to IS prime and IP, if you remember. But IS prime, it has reflection. But anyway, you get the point.
Yeah.
Let's do the KVL. you will have EP prime or ES. So let's use ES, voltage rise, minus IS prime times RS plus JXS minus VS.
Isn't it says IS instead of IS prime?
You are right, that is IS, not IS prime. A smart student would replace the negatives with an equal and a plus. And now you have the KVL equation number 1. Plug the numbers, calculators. A smart student already stored this number in the calculator, right? Correct? What is RS? 0.005 plus J 0.006 plus VS, it's 277, angle 0. No need to write angle 0. Calculators. A smart student has already this in the answer. No, not yet. Because we found the angle separate. You should have, this what's gonna kill you in the test. These numbers. If you don't know how to deal with them using a calculator, like today, you didn't bring this calculator, you rely on the iPad. The iPad will give you the numbers faster, so you're lying to yourself. Open the parentheses, don't forget them. Plus 277, and I should get this number.
279.7.
279.7, angle 0.182 degrees volts. Okay,
لم يرقم
because you didn't practice. Did you get it right?
That's with me.
أي
0.17.
Okay, let me know if there is a mistake. So, what is the second thing I need to do? I need to find IP prime, which is IE prime plus IS. What is IE prime? EP prime or ES over RC plus prime over ES over JXM prime plus the IS. So a smart student would have the answer where? Here. No need to retype it, we just found it. A smart student. So the smart student, please do it. Open parentheses. Answer over RC prime 60 plus answer over 12 times J plus IS. What is IS?
minus 51
361 and minus 51. So what is IP? 377.7 at angle minus 34.5. The smart student would carry this information and develop a new KVL, right? Remember, it's a KVL, and then a KCL, and then another KVL. So, what is the other KVL here, right? It is VP prime minus IP prime, RP prime plus JXP prime minus ES equal plus. Okay? A smart student have this as answer, so I'm going to write it as answer times, this is my answer, I just found it. Correct?
Yes, right.
Do not retype the numbers. This will take time from the exam. Answer times, what is RP prime?
كم الزاوية؟
This guy.
54.5.
0.006 plus J times 0.00072 no, 2 zeros, not 3 zeros. And then plus ES, what is ES? 279.9 at an angle of 0.18, whatever, 6, whatever, doesn't matter. So the smart student would find the answer to be 283.3 at an angle of 0.378 volts. So what is the VR? VR is voltage at, so let me tell you this and please focus. YouTube, previous section, focus. Because Saudi Electricity Company flagged this load as a rated load, they are obligated to have 283 as the primary terminal reflected to the secondary. The moment that we disconnect the refrigerator, that is 277 directly, what is the voltage that appears in the load side? Given that Saudi Electricity Company is thinking 283 has to be applied, it's the same, 283. Minus, this is the no load voltage. What is V full load? Connect back the refrigerator. Now the load will have 277. And the primary reflected would still have the 283. So minus 277 over 277 times 100, and you should get 2.2%. This is the proper percentage. Okay? Now, it's not only that. In the example here, they used what? Here they used circuit 2. So you have two things to learn from. Practice circuit 2. I forgot to tell you the quiz up until here. Up until slide 91. Okay? To make things easy. It is not only that, let's analyze how he did the efficiency. First of all, how he did the efficiency, he calculated the output power. What is the output power? Is the rated apparent power, ya Mu'ad, of the transformer, which propagates all the way to the load times the power factor. So we are at 85 kilowatt. You can solve the current. When we find IS, you can use this and continue. You will get the same IS. Okay, everything is interconnected. What are the copper losses? Here he used circuit 2, referred to secondary. So he combined RP prime with RS into 0.011 times IS squared. What is the core loss? He used VP prime. Or you can use EP prime. Or ES squared divided by 6. He got the efficiency to be 96. So this is, let's say, a medium transformer. Medium efficiency. So low efficiency of a transformer at what percentage?
90.
High efficiency?
99.
Nah, this is maybe above average. Okay? With that, I conclude this lecture. You can solve all the examples here by yourself because they are the same material. Okay? So next lecture we might go over them. I don't know, we might solve them. And then we'll jump to the three-phase transformer. We are a little bit behind in the syllabus, but that is okay. Why? Because we would rather learn the proper way than rushing things up. Okay? Inshallah, we will catch things. We will have additional virtual lectures with attendance, okay? With attendance. Thank you so much. Do you have any question? You're free to go.
شغال؟
واضح.